All right, so let's take a look at chapter 2 now. Let me share my screen really quick. And so chapter 2 can be accessed from in your textbook from the Unit 1, Mechanics 1, Motion and Forces, and it's called Dynamics. Okay, so in chapter 1, we learned about velocity, acceleration, and how to describe motion and how all of these quantities are related. Now, in chapter 2, we want to identify, what is causing that motion. So we're going to talk about Newton's laws of motion. So this is really, a very important part of this chapter. We're going to look at some applications, and in particular, you'll see that Newton's laws of motion rely on the concept of force. And we're going to take a look at some examples of forces. So if you take a quick look here, you'll see that we have what we call the spring force. We'll talk about gravitation, friction, normal force, and tension. But so as we get started, you have the usual section that introduces this chapter. Then we talk about forces. And then we go through each law of motion. So first, second, third, and then we go over some examples of forces. All right, so we're going to navigate this quickly together. Again, I would encourage you to, actually read this, and I'm not going to do it here. Otherwise, we would be here for hours. This is putting things in context, and, Newton's work in, identifying these laws of motion. You'll see that this chapter relies on chapter 1, because as we talk about Newton's laws of motion, we will talk about acceleration, we will talk about velocity. So it's important that you have these concepts down to explore chapter 2. Okay, so there's a bit of historical context, and then you can see it even starts going into modern physics a little bit. And then we have an introduction, to the concept of force, and, explaining what dynamics is. And really, we're going to be, identifying an object, looking at the forces that are acting on this object. And you'll see that once again, there is a vocabulary that is attached to this. So we'll be talking about a force exerted on something by something. So that's going to be extremely important, especially when we talk about Newton's third law, but I'm jumping ahead a little here. So here, definition of force, right? You have the summary with the glossary that has the definition. And then we go over each one of the laws. So first law, and you're given the definition in words. And so these laws are extremely important. They will show up, regularly as we go over the rest of the chapters. You'll see that we'll be introducing new forces. So eventually, for example, we'll have electric force, etc. So we're not there yet, and we're not going to get there for a while, though things are moving quickly. But this is very, very important that you understand the 3 laws of motion and how the definition, but also you'll see that they're also related. So all right, so first law, and with the first law we introduced the concept of inertia, and this law is in fact usually referred to as the law of inertia. The concept of inertia is related to the mass. So very important concepts that are introduced here. And again, I'm not going going over these definitions now because you do have the lecture videos that go into more details. Then we go into the second law. This one we use a lot, especially when we're trying to find relationships between the forces that are acting on an object and its acceleration. So this one is the one that we usually use when we have to work out, values of the forces or accelerations. So when you have to do calculations, that's often one that you're going to be using. All right, so again, it's going to be stated here. And it's given in words, but you'll see that because it depends on variables like the acceleration, the mass that we just talked about in the previous page, and force. And basically you can see that acceleration is going to be, this symbol tells you that it's proportional to the net force. So this is net external force. This will be defined also. It's also inversely proportional to the mass. And so then you end up with, a statement of Newton's second law that you can also write out as, F equals mass times acceleration. All right, and then because, this is really the first time we use the force in an equation, it's important to figure out the units for force. So this is explained here. And then we have one more. So we jump to the third one. And this is where I was telling you, so you have some examples. So definitely check those out. Again, learning physics is really sometimes easier when you learn by looking at some applications and examples. So then you have a statement of the third law. And again, this is stated in videos, but this is also where it's very important to identify the object of interest or system of interest. So is the action, so is this force acting on which object, and what is the system that is acting on your object of interest. So those are important things to think about when you're analyzing a physics problem and identifying forces. So again, it may be overwhelming right now because we're going over this very quickly. I just want to give you a very quick overview of this chapter. Okay, and then you have, you're introduced to examples of forces, so different scenarios. Normal force, so this would be, for example, when you set, so you can see an object on the table. We know that there is the gravitational force that's pulling it downward, but why is it not falling through? It's because the table is acting on the object, and that force is called the normal force. It's upward, and you can see it's exactly opposite to the weight of the object. And then related here, you have the tension. So tension is force that exerted by, so you can see an example here, a rope. And you have, different sets of examples that are also given here. Okay, so this is a classic example of a person in an elevator. All right, and next time you step in an elevator, you can essentially really think about those concepts. Why do you feel lighter or heavier at different times in your ride on the elevator? And that's all explained right here. All right, with the concept of apparent weight. Then the spring force that is given by Hooke's law. So Hooke is the physicist. Hooke's law gives us, so it's given here. And it essentially gives us the magnitude of a force given by a spring, and it depends on x. So here, this is the displacement of the spring related to its equilibrium position. All right, so you have some examples. This is a vertical spring, but you can have a horizontal spring as well. All right, friction, a very important force that we tend to ignore a lot of the time. This is why, you know, if you're sliding down on the ground, you're going to stop eventually because friction is acting against the motion. This is also why, you know, when you're moving furniture around, you'll notice that, you know, it's harder to get something to move. So if you're looking at this crate, you'll have to exert more force to get it moving. And once it's moving, you're still going to experience friction, but less so. So this is all explained here, looking at the difference between static friction and kinetic friction. All right, you can see you have some take-home experiment if you want to. And also figuring out, you know, what is happening at a microscopic level to figure out, you know, understanding what is going on here with this force of friction. Another example, and that's we're going at a different scale here, is the universal law of gravitation, a very important law, especially when we're looking at the motion of, you know, planets around the sun or moon around the Earth. You know, when we're calculating weight, as it turns out, that is all related to this universal law of gravitation. So it is stated here. This is a very important law. Again, these are concepts that are used for things like, you know, if you're trying to launch something towards Mars, you need to account for, you know, various objects and, you know, these forces and how they're going to interfere or contribute to the motion of, you know, your rocket, etc. It also, you know, you go into the concept of tides in this, and, you know, what it means, you know, to experience weightlessness. And this is a picture on the ISS, all right? So we're going from the very small, right, when we're looking at friction, to the very big. And then you can see we're back to centripetal force. So we had talked about this before in the previous chapter, but we're going a little bit deeper. So we had talked about centripetal acceleration or circular motion. And then we can figure out, okay, so what is the force responsible for this? This is going to depend on the scenario. It's very interesting. And it has so many applications. So for example, here, you're looking at a car on a curve, but there are very many applications of, like, when you look at any object in circular motion, trying to figure out what is the force that is keeping your object in circular motion and not, you know, flying off. And then you jump to the exercises, but you can just continue on with your homework. So just like with the previous chapter, you'll have a pre-chapter check. So again, for those of you who may have taken physics before, you can see if you want to jump straight to your homework set, or if you need to, you know, study some of these concepts and either read the textbook, watch the videos that I have on the course content page, or you know, other videos if you prefer. There are many out there, especially when we're looking at Newton's forces, Newton's laws, and their applications. All right. And as always, please don't hesitate to reach out if you do have any question.